It's a real pleasure to be here. I've met some of you already today at the Confluent booth. So I'm going to be talking to you today about building event streaming apps with Apache Kafka and Confluent. So my name is Mark Teehan. I work for a company called Confluent. We're just a 4-year-old company based out of the United States, and now we're running an office out of Singapore in Asia Pacific. I'm based in Singapore. So you can reach me, my email is there, and you can also reach me on LinkedIn. I'm not really on Twitter. And there's a strong link between Confluent, my company, and LinkedIn, because the 3 people that founded Confluent all used to work for LinkedIn. And they built something in LinkedIn, and I think in the great tradition of Silicon Valley companies, LinkedIn donated it to the Apache Software Foundation, and it became Apache Kafka. And now Apache Kafka is one of the most popular data streaming platforms in the world. It's used in thousands of companies in production, and Kafka systems process some of the biggest data loads of some of the biggest companies in the world. So many of the big ride-sharing companies, the food delivery companies, the digital broadcast companies, and increasingly banks and airlines and these sorts of companies are using it. And I'll talk a little bit about what it does as we go through. So I build highly scalable hello world applications. So in the great tradition of software engineering, the first thing you do on your first day is you build a hello world application in the language of your choice. Budi, I'm sure, has been through with many students through this, but they're highly scalable. We all aspire to build simple applications. Nobody tries to build something that's incredibly complicated, but they're not necessarily primitive applications. They do more things than once. And this quote is from Kenny Pastani. And as we strive to create applications, we keep them simple and modular. We have a single function that we're trying to achieve. We build out that application, and things develop. You need new classes, new modules, new functions, and you build those alongside your existing applications. And your functionality starts to spread and to grow. And of course, you start putting more data through your system. And nobody ever builds a system and your volumes of data start going down. The natural evolution is you start processing more data. And you start scaling up. Things start getting busier. And as time goes on, the natural evolution of systems is they become a bit more unruly, a bit more difficult to govern. You have different frameworks, different versions, different teams working on different things. And it can get difficult. There are sometimes areas of your application landscape you don't really want to shine a light on. Things that you know are imperfect, it's just a consequence of busy teams, deadlines, things to be delivered, and they get hard to manage, right? And this is really the evolution of modern applications. This is the way it's been done for decades, and it's worked perfectly well, for a long time, given the technologies that were available. These are largely database-based applications. They went through various names and evolutions of sort of being multi-tier and client-server and various different sorts of stacks. But we currently more or less call these monoliths now, because they're self-contained applications. They have some sort of infrastructure and data storage at the bottom, then lots of processing at the top, and some sort of a user interface at the start. And the difficulty with monoliths is they're hard to think about. Like at one end of the scale, you have your sort of enormous, incredibly complex systems that you would buy from vendors, ERP systems and things like that, with 200,000-300,000 tables. All the way down to something that your organization may have built over time. And often the reason these are hard to think about is because the expertise is in someone's head. It may have been the original architect or designer of the system or principal developer. And because teams change and people change, and it's always been a challenge to maintain a steady sort of knowledge and governance over systems as they develop. And of course, they're also hard to change. Systems are complex, the dependencies are not always obvious. So these are very much the everyday challenges that all of us as software architects or developers, system designers or testers are dealing with all the time, is trying to understand the consequences of changing anything in the systems that you're dealing with. But change they must. I mean, no system stays static all of the time. All of our industries move at different paces. But ultimately, there's always a need to change the systems that we're operating on. And the current trend, and I think a way out of this really is refactoring to microservices. We see this increasingly. Confluent is a very interesting company in the two main types of customers that we deal with. On one hand, we're sort of a darling of the digital native companies, the sort of ones that I just mentioned, largely across California and the United States, but also increasingly for digital native businesses all across Asia Pacific. And again, it's the ride sharing and the food delivery and travel booking sites and all these sort of things. Anyone that has a lot of data, they tend to be ours. And at the other end of the scale, a very large section of our customers are banks, retail banks, investment banks. And they have a different set of challenges. Often they're perhaps dealing more with monoliths, dealing with systems that have been around for a long time and trying to figure out the best ways, the best sort of technologies to put in to be able to interact better with those monoliths. And refactoring to microservices is a very popular a trend at the moment to do that. And largely that means taking existing functionality and sort of chopping it up into more manageable pieces, right? So you look at the entire scope of what an application does and think, well, how do I make this into more bite-sized pieces that I will be able to recode? And the difficulty with refactoring applications and taking functionality back apart again is you have to think about how do they all communicate with each other. So you have to think about the reintegration part. When this is a monolith, this is not really an issue, because if it's a client talking to a database, they're all within the same domain. And you never really have to think about the principles of how different functions communicate with each other. But this becomes an issue if you're trying to recreate something as microservices and trying to stick to certain principles about how that should be built, then this is something you need to think about. And it's not like an Oracle database talking to a Java application. Communication with microservices does become more complex. And ultimately, there is no good way to integrate microservices. I'm going to go through a number of suggestions that are often chosen, and then I'll propose one that perhaps is a better option. So everybody knows file systems. Everyone understands what a file system does, how it works. It seems like a really easy option to just communicate via files. One process writes some data to a file, the other process opens up that file and reads back from it again. And given that we have so many software architects in the room, I hope that you will put on your stern face and say to any developer that suggests using files from microservices, no way. Don't do it. There's a whole bunch of reasons why this is a terrible idea. Then you may say, well, why not do a database? I mean, everybody understands SQL. Everyone knows the role of a database for communication. But ultimately, the problem here is a database is not built for doing this sort of a communication. A database is a data storage technology. It's not a data communication technology. And everyone has a database and they know how to use it. Every single developer knows how to write a select statement, so it seems like an obvious choice. But the difficulty is it causes services to commingle. One of the principles of a database is that you don't duplicate your database, right? If you have a good DBA and the DBA is saying, well, no, you can't just copy your table and do something else, you use the other tools available within the database in order to make your data available elsewhere, but you don't copy it. But this has created an issue with microservices because you're trying not to commingle data between your different microservices because it violates the bounded context for microservice processing. It's okay to use data stores within a microservice, but actually for communication across microservices, no. We think, no, it's a terrible idea. It's not for negotiating change. And then the third option really is remote procedure calls. I mean, why not use those? It feels like a much more natural fit for microservices. It's a process, and it's not a file system, it's not a database, so why not use it? And we're getting closer to what we should be using for microservices, but we're still not quite there as well. So it does avoid the problems of database integration. And procedure calls, to take off the R from RPC, procedure calls feel quite natural from a microservices point of view. And it does align with request and response, but then you get into difficulties of cascading failures, and debugging, right? So as you start to do procedure calls in parallel to different services, anyone that codes something like JavaScript, trying to do parallel calls back to some sort of a data store, and then try and figure out how to debug things when they go wrong. It's actually extremely difficult. And it introduces a lot of complexity that you really don't need to deal with. So our response to this, perhaps unsurprisingly, as the company that's behind Apache Kafka, is that you use a log. So a log is one of the, we all know what a log is. We've all dealt with logs before. We've all read them. Are we talking about a log4j sort of log that we should all be familiar with? I mean, and ultimately, I'm clearly not going to suggest that you use a log4j log in order to communicate between microservices, but actually many of the principles in a standard log file are the same sort of principles that we're trying to aspire to here. In that, look at what is a log? It's a history of events that have occurred. They're in a specific order, and once they're written, they don't change. Okay, so these are all very, very important principles. And if it's really a series of events, then we need to think a bit about what exactly do we mean by an event. Okay. Oops, I'm sorry. And it's a shared narrative describing the evolution of the business over time. There are, as you get into event processing, some of the principles behind it, and there are a number of bloggers and speakers in this area. I really like Martin Fowler, who writes a lot for ThoughtWorks. And there are a number of processing strategies, such as CQRS, etc., around events. But ultimately, it begins with a definition of what an event is. And at its simplest form, an event is simply something that happened, right? And because we're building systems for business, an event is something that happened in the business, all right? So if we build our systems around the principle of recording events that happen in the business, then how does that change the way that we would build new microservice applications, and how does that change the way that we would refactor microservices and make them communicate in a different way instead of using events? An event is ultimately a combination of two things. So it's a notification and a transfer of state, okay, for that event for the business. And a very critical property of events is that they are immutable. Just as if you as an IT manager asked the DBA for the database logs for last week, and the DBA went and edited the database logs and opened them in an editor and changed a whole lot of stuff, you would find that deeply offensive, because you don't change log files. The whole point of a log file is they are immutable; they do not change, right? As you build event processing systems, sometimes there's a temptation there to think about, well, I need to change my event. Something happened before, and then in my business processes, whatever that was, changed. So I want to go back and change my event. And that's one of the principles that you can't violate for event-based systems. You can send a new event, which replaces the earlier event, but it's not possible to change an event that has already happened in the past. It's an important principle. So the core abstractions of the different ways that you could communicate between microservices. If you're using a database, then you write your data to a table. It's a terrible idea, and as software architects and all that, I hope you would never allow this for microservice systems. If you're writing to a Hadoop-based or any sort of a big data system, you simply write it into a file. But what if you are writing to a Kafka, and it's actually a log? Okay, so we're kind of back to the whole ideas again of logs. And and we're not talking about the log4j kind of log, we're not talking about the Arnold Schwarzenegger kind of log. But at its core really is the fact that Apache Kafka is a global aggregated log store. So when you deploy, Apache Kafka is open source. Okay, so just like Linux and Spark and like 300 other technologies at the Apache Software Foundation are open source, so is Apache Kafka. You can download Apache Kafka, you can run it on Linux VMs, you need 3 machines to run it, and basically it starts waiting for data. So you can write applications such as a microservice that does a hello world, and you can send a hello world to Kafka, and it'll write it into a topic. And then you can have consumers that are listening to the topics, and they say, I'm interested in everything that lands in this topic, and it'll receive the data and do whatever it wants to do. It might change the data and send it back into another topic where something else could be listening and sending it out. In the case of businesses like, say, food delivery, there's a lot of interaction between all of the different processes that are sending and receiving data. So the processes that are interacting with the delivery people, all of the spatial processes that are needed in order to send them directions and where they're going, dealing with the customer, dealing with the vendor. All of these sorts of things would be deployed as many microservices around an Apache Kafka system. And a system like that may have, say, 100 topics. And you can think of topics largely like a database table. I mean, each one contains a distinct set of data. And producers, ones that are generating the data, are writing their data in. And anyone that's interested in that are receiving the data back out and doing some change, doing some sort of a check and writing data back in. So you end up with these very complex data flows occurring, and it all centers on Apache Kafka, where Kafka is basically coordinating delivery and receipt of this data across all of the different systems. It doesn't sound terribly difficult, and it doesn't sound terribly different to the way that a database would do it. And we talk a little bit about why Kafka rather than other event streaming systems first. But I think one of the important differences, one of the important things to keep in mind with Kafka is it's used across the entire spectrum of data processing, right? So companies that start up small and say, you know, we're not going to give all of our money to Oracle, we're not going to give all of our money to IBM, so we're not going to have lots of vendor software. We'll be as open source as possible, and we're going to be an event-driven business. So we're going to think about everything that happens across our enterprise as an event, and we're going to treat it like an event, and we're going to be as close to real time as we possibly can, right? So and that could be at the very low end of the scale where you're dealing with 20 events per minute, you know, whatever kind of business you're doing. And at the very top end of the scale, it really doesn't matter how busy your business is. It doesn't matter how creative you want to be with how much data you're going to generate. And particularly for the very, very hugely distributed applications like ride-sharing and all that, and the travel bookers, where they have, you know, hundreds of thousands of or millions of applications installed, all generating data. Kafka can deal with this volume of data. There's almost no limit of data that you can throw at this. One of my customers at the moment, one of the food delivery companies, at peak, they do 4 million events per second. And they can sustain this for 3 or 4 hours on their system. That's just a normal dinner time peak. So vast amounts of data. There's a lot of sort of complexity about what happens inside the platform itself, but ultimately it's 3 Linux machines, you install Apache Kafka, and then you can start sending data in and out of it. That's essentially what it is. And there are a number of reasons why Kafka in particular is a great platform for building microservice-based applications. I would say microservices are probably between 30 and 50% of the organizations that I talk to. I work in pre-sales, so I support our sales team, and I work with organizations that are either looking at re-architecting their systems, or they're already running Apache Kafka, or they're running monoliths. It's very common to say, like, we built a big stack and we used, you know, Postgres and MySQL and all these programming languages and all these UIs on top. But we want to move to something else, and I work with them to figure that out. And there are a number of things that you need as an organization to do this. First is delivery guarantees. Okay, a delivery guarantee is really a contract between the system that you're using and the business that's using it, saying, you know, what's the quality that I'm going to get from this. And the first is, obviously, you will never lose any data. You know, no matter what happens on your systems, your system is saying to you, Kafka saying, I'm never ever going to lose any of your data. And that means that you can pull the plugs on servers, you can shut a data center down, you could have an earthquake, you can do all sorts of crazy stuff, and the idea is no matter what happens across all of my servers, I'm never going to lose any data. There are actually plenty of circumstances where it's okay on systems to lose data. A lot of our Kafka users are dealing with clickstream data, sort of mouse movement data for applications, and later data replaces earlier data, and there's always a cost decision around building additional guarantees onto your data. So sometimes they say, look, we have this much budget for this system. We don't need this level of delivery guarantees because we have so much budget for a system. And the other delivery guarantee, which matters much more for banks, is not only am I never going to lose any data, but I'm never going to duplicate any data. And again, you can do whatever you like to the system in terms of failures, multiple failures cascading across the system. I'll never duplicate the same event twice, even when you're sending me 4 million per second. And that's actually a very, very difficult thing to do in a distributed system. One of the great challenges of these huge distributed systems is guaranteeing that you never send the same data twice. And it's something that we've put a lot of engineering into over the last 2 years, but we finally achieved that last year. Service goals. You can decide, I want to build my system for latency, or for throughput, or for durability. So we have 4 major service goals that we build systems for. And we can sit down with system architects and say, well, what's your service goal? You know, what do you want to get from the system? It's not necessarily durability. There are circumstances where other sorts of service goals are more appropriate. Performance. We have kind of the trillion events club. So the companies that cross over 1 trillion events per day, The biggest in the world is still LinkedIn. LinkedIn do somewhere in the order of 7 trillion events a day. Microsoft do about 4.5 trillion a day. Uber do about 1 trillion. Netflix do about 1 trillion. I think one of the first, a lot of companies don't like to reveal these numbers, and there may well be other ones that are doing more than that, but probably one of the first in Southeast Asia to cross 1 trillion, maybe Agoda.com, the travel booking site up in Thailand, who really, I think they're at around about 700 billion a day at the moment. So performance is really not an issue for this. Kafka is a very strong community. This is one of the really important things, in my opinion, on being able to develop a platform that your company can really sort of bet its future on. Apart from meetups and summits, from the general community, it actually has a very strong community of advocates. People get really passionate about Kafka. I'm going into new organizations regularly, and there's almost always someone at the table who just loves Kafka, and they're kind of eyes well up a little bit when they're talking about the things that they can do with Kafka. And often it comes to the attention of perhaps a CIO that Kafka is already running, it's in production, and it's got lots of data flowing through it, and it's critical because somebody really liked it from, say, a Unix sysadmin team or from the big data team or something like that. So that's often the case. Lots of different clients. You don't have to be Java. You can be Python or .NET or Go or whatever. We have all the clients for that. Schema management. It's not unusual to have Kafka systems put into or any data processing systems put into production without any real thought of the governance of what data is flowing through this. Databases forced you to do this, and a lot of systems that have gone into production, I'd say over the last 10 years, it's kind of like building a database table with just like a primary key and a club, some sort of a big data object that could contain anything. It could be text or video or audio or anything at all, it doesn't matter. And a lot have gone into production like this. So schema management has become a feature of the last 2 or 3 years to make sure that you know exactly what's flowing through your topics. This is really important, particularly if anyone in a regulated environment, if you're a bank or if you're dealing with anything of a financial nature, it's really important to know that you know what's flowing through your system. Enterpriseness. You have to be able to do disaster recovery. You have to be able to do have a CI/CD chain into production, all of these sorts of things. Kafka has all that, and it runs anywhere. On Linux machines, on VMs, on Docker, on Kubernetes, on managed on cloud, self-managed on cloud. So it's really important from a cross-platform point of view that you don't put all of your eggs in one basket that could become problematic in the future. And increasingly we're finding clients going absolutely multi-cloud. Yes, we're going to deploy, but we're going to use multiple cloud providers, and we demand an identical product across all these cloud providers. So it's really important. And increasingly, we're seeing Kafka emerging as a serverless technology, so a managed Kafka on cloud, which is one of the services that we provide. There are others, but we think that we're offering the true serverless Kafka on cloud, where it's almost like a dial tone for a Kafka system, where you can send it really large amounts of data. The pay-as-you-go system does 100 megabytes per second, which is, can be in the order of 1 million events per second for like 60 cents an hour. It's really quite good. So fine. So that's everything I wanted to cover. So I hope that was useful. I would encourage you to go to some of the resources that we make available as a company. In particular, Slack. Anyone that's here on Slack, please look up Confluent Community. It's got around 10,000 users at the moment with about 10 or so channels. One of them is events and how to build event processing applications, both from a ingest and egress point of view, but also event processing. What are the various principles behind this? So please have a look at that. We do a lot of meetups, including here in Jakarta. And this blog was just published a couple of days ago. So building shared state microservice for distributed systems using Kafka streams, getting more into the data processing side of things, which I didn't talk about at all today. But there's a whole bunch of different technologies around how do you build event streaming systems with a streaming component built into the whole data flow. And in this case, perhaps unsurprisingly, our recommended tool is Kafka Streams, which is a Java library. So I do recommend this, just released recently. And that's it from Confluent. I would suggest Kafka Summit is coming up in a few weeks. If it's in San Francisco, it's the biggest one. We're expecting it should be more than double the size this year of last year. And all the material will be on SlideShare and LinkedIn afterwards. And it's hundreds of slide decks of really, really valuable information about the principles of building event streaming systems and using Kafka across all this. This is not Confluent organized this, but it's not just for Confluent people. There are lots and lots of Apache Kafka users out there that don't use Confluent that participate in Kafka Summit. I was really encourage it. If anyone is lucky enough to be able to go, then there's a discount code there available because we offer discount off on the admittance for that. And that concludes my talk. We have, it just started flashing orange. If that's okay, so I think that means I'm up. So thank you very much. I hope that was helpful. Thank you.